Okay, so we're going to start by talking about, we're going to put a lot of pieces of information together, okay? So back when we talked about equation works in Unit 2, okay? All the way back to Unit 2, we solved one-step equations, okay? So we're going to start there today with our foundation. Then we're going to build up to what we did in our last unit, which was ratios and proportions, okay? So we're going to build on top of that. Then we're going to take it one step further and we're going to add all of that information together to solving some problems with similar shapes, which is what we talked about yesterday, okay? So today we're going to be putting lots of pieces of information together, but the good news is all of it's stuff you have done before. It's just a review and adding it together, okay? So we're going to start with one-step equations, and we're just going to do a couple of these. Let's say we have the equation 5x is equal to 30. Can somebody tell me how we would solve that equation? How would we solve this equation? Janessa?
Divide.
Very good. So we would draw our line down our equal sign. Everybody put this problem on your whiteboard, even though I know it's pretty simple. We would put our line down our equal sign, okay? And then we would divide, because 5 and x are currently being multiplied, so we have to do the opposite. So if we divide both sides by 5, these cancel, so we have x is equal to 30 divided by 5, which gives us 6. Nod your head if you remember this. Yes? Okay, let's do one more. You guys try this one on your own.
How much of an eraser?
4x is equal to 28. Go ahead and do that one on your own.
Is it 40?
Solve it on your own.
No,
All right, so we draw our line down our equal sign, divide both sides by 4. So x is equal to 28 divided by 4, which is 7. Okay? So that's our first piece of foundational information we need before we can move on with the next step. Thumbs up if you got it. Remember. Good?
No, right.
All right. Now we're going to apply that to solving ratios and proportion. Can somebody remind us what that means? What's a proportion?
Half?
Olivia?
when the unit rates are the same.
Okay, so it's dealing with unit rates and ratios. What does a ratio look like? What can a ratio look like? There's lots of different forms. Ollie? With a fraction, okay? So a proportion, if you remember, looks like that. So we have two fractions and they're equal to one another. So draw that on your whiteboard, okay? That's a proportion. Okay, so we're going to have proportions today to solve. The only thing you're really going to be adding to this today is you're going to be using shapes to fill in the proportion. But we're going to practice solving a few of these first, okay? I'm going to start with this. 3 over 4 is equal to x over 8. In any type of problem like this, what is our goal? What are we trying to figure out? What is x equal to? So we need to figure out 3/4 is equal to what over 8? Raise your hand if you can look at this right now and tell me what x is equal to. 3/4, if these were equivalent fractions, x over 8. Raise your hand if you can tell me what x would equal right now. Okay, Ruth, what would x equal? 6. It is 6. How did you figure that out? All right. How else did you figure that out?
It's 4 plus, or 4 times 2 is 8, and 3 times 2 is...
Right, you use equivalent fractions. You know what equivalent fractions are. 3 times 2 is 6. 4 times 2 is 8. Did anybody else do anything differently to figure out that that one would have been 6? Ollie? Yeah, you could also do the opposite. So he would say 8 divided by 2 gives him 4. So what divided by 2 is going to give him 3, and it would be 6, okay? So there are going to be times today where you're going to set up your proportion and you're going to be like, oh, duh, I can fill it in. And that's good. But there are going to be times where you're going to look at it and you're not going to be able to do that. So we're going to show you a strategy to solve it, okay? So we know this is 6, but we're going to solve it anyway, okay? And then we'll see if we got it right. We're going to use the strategy cross multiply and then solve for x, okay? So what it looks like is you're going to draw an x, and some of you will probably remember this, okay, in the center. Then you're going to rewrite your equation with what's connected with the x, okay? I like to start with my variable on the left-hand side just because I think it is easier for me to solve. But if you put your variable over here, that's fine, okay? So I'm going to look and see my variable is attached to what number by this line? 4. So I'm going to put 4 and x together. When you're cross multiplying, the operation is multiply. So we can put our variable right next to our number, okay? Then I'm going to look at what's connected by the other line. So my other two numbers are 3 and 8. I'm going to multiply. What's 3 times 8? 24. Okay? With me so far? So we draw our x, we connect through multiplication. We cross multiply. 3 times 8 gave us one side, 4 times x gave us the other. Now we just have to solve. So we draw our line. We divide both sides by 4. So x is equal to what? 6. Perfect. Okay? Did we already know that x is equal to 6? Yes. Okay? Again, if you can look at it and figure it out by using equivalent fractions and simplifying, go for it. But if you can't, this is another strategy. All right, let's do one more. Okay? Sorry. Let's do the number 4 on that. All right, so 9 over x is equal to 12 over 4. Again, we're trying to figure out what x is. What's our denominator in this fraction if these are equivalent fractions? Okay, so we're going to start by drawing our x in the center. All right. Can somebody tell me what my two sides of my equal sign are going to be? 12x on one side. What's on the other side? What's on the other side? How'd you get that? 9 times 4, right? Okay, 36. All right, so cross multiply. That's the important step. Multiply. 12x. 9 times 4 is 36. We draw our line. We divide by 12 on both sides. So x is equal to 36 divided by 12. Anybody know what that is? Sophia? 3. Beautiful. X is equal to 3. Okay? So if we were to plug this in, we would want to make sure that that's true. Okay? 9 divided by 3 is 3. 12 divided by 4 is 3. 3 and 3 are equal, so we know that's correct. Okay? So we're going to cross, multiply, and solve. Now, let's talk about how that applies to similar shapes. Okay? Tell your partner real quick, what are similar shapes? We talked about this yesterday. Talk to them about it. Oh, you need to make sure that this is this part visible now. You like our setup and shape?
Yeah. Did you see that? Like, would you get me a marker?
Perfect. And you don't have to see the words. That's okay. Thank you. Good job. All right. Who can tell us what similar shapes are? What are similar shapes, Nehemiah?
Shapes with the same, same shape.
Same shape, different size. Beautiful. Everybody look up here. Same shape. If you're watching this video, you might want to write this down, but you guys don't need to. Different size, right? Same shape, different size. So let's, okay. Would you agree that these are similar shapes? Yes? Okay, good. Okay. So when we're looking at shapes, same shape, different size. Okay? I have a question for you. Look at these two. You said these were similar. You guys can stop with the markers for a second. I'm going to draw another shape.
No.
Are those similar?
No.
No, but they're both triangles. They both have three sides.
But they're different shape.
Okay? They are different shapes, right? We see that this triangle has a right angle. We see that that triangle does not have any right angles, okay? So they're not similar. So pay attention to that because that's going to trick you, okay? So let me redraw the pretty one, okay? This little square tells us 90-degree angle or right angle, all right? So let's put this and this together into one, okay? So we're going to redraw on your board these triangles. Go ahead and draw two right triangles, one smaller than the other. Go ahead and draw those. Two right triangles. Okay? We're going to say that this side of this triangle is 9 inches. And this side is 6 inches. So if that's the case, and we know this one is 3 inches, our goal is to figure out what is our long side on this triangle. Okay? So what you're going to see today are problems where you have two shapes. One shape is going to have a lot of information labeled. It may be two sides, it may be all three. Okay? The other shape, there's going to be a side length missing. And that's our goal, is to figure out what is the length of this side right here. What's our x equal to? Okay? So this is where we're going to set up one of these. We're going to set up a proportion. Okay? So let's look at the information we do have. We have a 9 and we have a 6. So I'm going to put 9 over 6. It really does not matter, guys, which one goes on top and which one goes on bottom, as long as you match it with the other shape, okay? So since I put 9 on top, and 9 is this long side over here, I need to put my x on top over here because it corresponds with that side. Does that make sense to everyone? Okay? So I want my sides to match. So x has to go on top here, 3 goes on bottom. There's my proportion. Okay? Now we cross multiply and solve. So we're going to draw our x. Okay? Can somebody tell me one side of my new equation down here? Layla?
X and
6 and x. Good. Can somebody tell me the other side of the equation? Sophia? 27. And how did you get 27? 9 times 3. Okay? Now we draw our line. Divide both sides by 6. I didn't end up with a pretty number this time, so I'm going to use a calculator. 27 divided by 6, 4.5. Okay? Now, one thing I want you guys to make sure you do today is after you get your answer for x, go back up to the shapes that you're working with and write it in. Okay? So x equals 4.5. The reason I want you to do that is to make sure it makes sense. Okay? If we shrink this triangle, okay, we've cut it in half. We went from 6 to 3 here, so we went from 9 to 4.5 there. Is 4.5 half of 9? It is, okay? So we just want to make sure that it makes sense. If our number got bigger, that would not make sense because our triangle got smaller. So go back up and put it wherever your x is and just look at it to see if it makes sense, okay? We're going to do one more example together. So erase your boards and draw two similar